Hello and welcome to today's video. So I haven't put out any videos in a while simply because I'm in writing code, and writing code is boring and nobody wants to see videos of that. So the code that I've been writing is to add support or new features that people have requested. This was originally developed as a battery pack sniffer. You just plug it in, it reads out the pack. It's very simple. It shows you the voltages and gives you the quick go, no go if you should buy a pack or not, buy that particular hardware or not. And people have wanted it to do a bit more, specifically pack monitoring. Since it can read the voltages, they're wanting it to say if your cell voltage gets above a certain point, they want it to flip an output or send a CAN message to shut off their battery charger. Or if voltage on any cell gets too low, they want it to send out a CAN message or toggle relay, whatever, to shut down your motor controller or your inverter. Or say if it gets below a certain point, you want it to go into limpo mode, you can toggle a bit. That kind of stuff. Wasn't designed for that, but certainly can be added. It's lacking a lot of the hardware to do that, but that can be added. I guess the other feature is a serial port. Some people want it to do RS-232. It does actually have a spot for a DE9 to get soldered on the edge of the board there, and a RS-232 level converter. So that can be done. And the other thing is CAN bus. It has one CAN bus which it uses to talk to the battery pack. If your battery charger doesn't talk at 500 kilobits per second like the Nissan Leaf battery pack, then you need to have a second CAN bus. So there's another option that people want, is a second CAN bus to talk to, say, a battery charger or a motor controller or something like that if they're at different baud rates. But other than that, everything else... Oh, and I guess the main thing that people really want is it to work with other battery packs as well. So there's been a lot of people asking for me to do the same thing for the Chevy Volt packs and for the Tesla packs and so on and so forth. So yeah, that can all be done if you know the baud rate and the CAN messages and how to decode them. I can totally do that. I can't test it here because I don't have those parts, but we can certainly get something to work out. And that brings up one other thing, is all this needs to be configurable, and that's what I've been working on. So I'm not developing on this because it actually runs that switch mode power supply boost converter, and that's done by the microcontroller. And if I pause it on debugger, then all the voltages collapse and it gets really annoying. So I don't develop on this guy. I develop on my little servo controller, which is what this was originally based on. So you can see it's got the same microcontroller on there, same USB interface, pretty much identical. Just more I/O broken out to run that display. So this is my servo controller, and this is what we're going to demo some code on. So what I've been working on is a USB mass storage device and a config file reader. So if we go ahead and run my code here, let it go and download everything. I probably should have done this ahead of time. You can see down here it's programming it. And eventually we will start running. Okay, we're running, and then we're going to hit my breakpoint that I've got here. So what I've done is I've read the config file that's stored inside the microcontroller. If I go over to variables here, so this all makes sense here in a second. I'm kind of doing it backwards, but you'll see here well, let's reorder these so that they're in the... There you go. So my air high voltage trip point I've set to 4.2 volts. These are in millivolts, so 4,200 is 4.2 volts. My warning high level is 4.1 volts. My warning low level is 3.7 volts, and my error low is 3.2 volts, and that'd be per cell. And my pack type is just 1, which means the Nissan Leaf battery pack. And what I'm going to do is we've now read that out of a config file that's stored in the microcontroller. I've created a little 8K removable disk. Here, I'll show you this. So if I hit run, Windows is going to pop up. So because it's plugged in, you can see it goes around to the other side, because I only have one regular USB port on this side. I have a USB-C port on the other side. I'm using the one USB to run the debugger. But anyways, so this is the drive. It's called Pack Sniffer. If we go to properties here, you can see that it's an amazingly huge 8K drive. I'm using up 2K of it. And it functions just like a regular little removable disk. It is a FAT12 file system, because that takes up a lot less room in my micro than a FAT16 file system. But you can see I've created this little sniffer.cfg file. If we open that up, we get all the stuff that it just read out. So we told it had a leaf pack. I have Volt in there. I don't actually do anything with it, but you can only enable one. So this is like an old-fashioned Windows INI file where you can go in and edit everything, and this lets you set the your limits. And I've got some outputs here, which I'm actually not reading anything. I'm not doing with these anything with this. But you can imagine how this would work. So we want to set up our voltage limits and go, oh, you know what? I changed my mind. I really want this to shut down at, say, 4 volts. And we're going to crank this down to, like, I don't know, change that down to 3.7 volts. And we're really going to be conservative, let's say 3.5 volts. And we'll leave that one at 3.2 volts. If we go ahead and save that, so we've saved it. Now if we close it, of course, it's a file. So we can open it back up, and those are the values. So 4, 3.7, 3.5, 3.2 volts. We close that again. We're going to go ahead and close it. Now this is really important because we're running it on the debugger. I don't have a way to unplug it, so we actually do need to do the old right click and eject it. And then Windows says it's okay to remove it. And then what we're going to do is just pause, and we're going to reset. And I'm going to run again. So remember the values that we had over there? Oh, well, they all went to 0, but we're going to go run again, and we're going to read the config file that we just wrote to the disk. So boom, we just hit again. So remember the values I changed it to? Error high is now 4 volts. Warning high is now 3.7 volts. Warning low is now 3.5 volts. And error low stayed at 3.2 volts. And of course our pack type is 1, which means the Nissan Leaf battery pack. So if I hit run again, you didn't like that. See, it's just going to pop it up because it's acting like you just plugged it in, right? But we can go open up this file again, and let's change this. We changed our mind. Oops, just an L. We changed our mind, and we actually want volt pack. So we're going to flip that over to volt, and I don't know, do we want to change all these? I guess we're going to go crazy. I don't know what the volt max is, but let's say it's 5 volts. Yeah, I mean, you wouldn't want to do this, but it's like a super battery. I don't know. But we'll just make that 5 and 4.5. And we'll go ahead and save that again. Go ahead and close that. Close this. Oop, you know, I should leave that open so that I can eject it. And we have to eject it if I actually don't have it running on the debugger, because it's actually powering the chip. So now I can hit pause here, and then we'll hit run again. And Windows is not liking that, but we'll run it again here, and we'll hit our breakpoint. Did I remember to hit? I might not have. Did I hit? I didn't remember. I think I forgot to hit reset. Then run. There you go. Now I hit my breakpoint. So you can see now pack type has changed to 2, which is what I just put in there for the volt. Error high has been set to 5 volts, and then 4.5 volts for the warning high and warning low, and error low stayed the same at 3.5, 3.2 volts. So you get the gist of it, right? That is what I'm planning on doing, is making it so you can adjust everything that way. and it shows up as a little USB mass storage, so you can use it on any computer system you want. It should work on anything. If you had the right cable, you could plug it into an Android phone or an iPhone and edit the file, and so you don't even need a PC. But it's much easier than building a whole graphical user interface and everything, an application that you have to run on the PC or on a Mac, or it's just, this is so much easier. So it's just going to be really simple. Plug it in, change it. The other thing I need to work on, so this is working. I haven't ported it over to the actual Pack Sniffer yet. I need to do that. I'll probably, when it boots up, I'll have it display different things. I'm going to have a bunch of different options in there, of course, so you can go in there and change it to do what you want. Like for the serial port, I can have it set up the baud rate, 8N1, all the parity, no parity, all that kind of stuff, how many bits. Same with the CAN bus. Set it up, say you enable the second CAN bus, you set up the baud rate, on high error, on error high, I want you to send out the following CAN message of 8 bytes to this address. It'd be something really simple like that. On error high, I want you to send, these 4 bytes on the serial port at this baud rate. It'd be pretty simple. So trying to make it pretty universal so it can be set up and people can use it for whatever they're trying to do. The thing is, when I add new battery types, there's a lot of decoding in there, so I'm probably not going to make that configurable to the point where I'll have to release new firmware. So to support a volt pack, it's going to require different kinds of packet decoding to break it out into the different cells and all that, and get all that stored into a data structure. So we'll have to have that data structure already pre-made ahead of time. And so when I add a new battery, it'll be a firmware update, and that's the next thing that I'm working on. Is now that I got the file system up and running, and I got it doing this, I want it to be able to, where you drag and drop the file into a firmware directory, and then that'll actually reprogram the firmware on the chip. So it would be the same exact hex file that you get, that it downloads over the ICD3 into the chip. It'd be exactly the same thing. So you can actually take the source code, compile it, get your hex file, and then just dump it to the chip over USB. So you wouldn't have to have an ICD3 or anything unless you wanted to actually go in there and debug. But yeah, that's the plan anyway. So maybe I'm gonna mod the ones that I've got. I think I've got like 2 or 3 left of them, and I'll modify those, and then I'll probably, if it looks like everything's working and people are really interested in it, I'll do another production run. It'll be like version 2.0, and I'll probably try to keep the same connectors on there, but I've got a few ideas on how I want to incorporate more I/O in it. Yeah, it's always the tricky part. Anyways, this video ended up being super long, but thanks for watching. Bye.